Hello everyone and welcome to chapter 7 of TMUA Simplified. Right. So in this chapter I'll be covering a very important topic, and that is differentiation. A lot of questions, like directly or indirectly, at least 5 to 6 questions are there which are based on differentiation. Right. So I will be covering entire thing in this video, right, and also uh, there will be questions at the end of the chapter for which I will be making video solutions as well. Right. So let's start. Now, before moving on to differentiation, let us understand what do we mean by slope at a point on the curve. Right. Before even that, we have to understand what is the meaning of slope. Right. So slope, as we all have studied in coordinate geometry, that it is nothing but change in y upon change in x, y2 minus y1 upon x2 minus x1. You can say delta y upon delta x. This is what slope means, right? Just to make it more precise for you, right? If there are 2 points on a line and I have to find the slope of this line, which is also defined as tan of theta, right? Slope is also defined as tan theta, where the angle theta is the angle which lines make with the positive direction of x-axis. So this is slope in general means change in y with respect to x. That is the slope of a line. Now let's understand, if we have a curve, not a line, like this. Now if I take any 2 points on this curve and join, suppose this, right. So for example, suppose I say this is curve for a function y is equal to fx. Now if I say, suppose, let me make it axis. So if suppose this point is x1 and this point is x2, so this is called secant line. So if I have to find the slope of this line, so we will find it in the same manner. But since it's a function form, since it's given in the function form now, so rather than just taking y coordinate, I can find y coordinate as f of x1 for this point, and for this point I can find f of x2. Now if I have to find the slope of this secant line, so I'll say f of x2 minus f of x1 upon, right, x2 minus x1. So this is the slope of this secant line joining 2 points on the curve. Now, since we have all of us have done a chapter called limits, so using that, if consider that these 2 points are very close to each other, very close to each other, that means the distance between them is approaching 0. If it is approaching 0, so in that case, if I draw a curve, same curve, and suppose I say there is this x1 and there is another point very close to it, which is on the left or on the right, anywhere, which is x plus h, where h is approaching 0. So if these 2 points are very close to each other, then the secant line joining them is almost a tangent, right? It will be touching the curve. So under the limiting case, where h is tending to 0, now y2 is f of x plus h, y1 is f of x, y2 minus y1 upon x2 minus x1, that is x plus h minus x. This will again give me the slope of this tangent, slope of the tangent, or a slope at a point on the curve, right? And this is what we define as dy by dx. Again, same delta y by delta x, but same thing, change, change in y with respect to x only. So that is what derivative means, or this is the process of differentiation. So now I can write it as dy by dx is limit h tending to 0 f of x plus h minus f of x upon h. So this becomes the derivative. or the process of differentiation. This is also called first principle, differentiating using first principle, ab initio also, right? So this is what is called. But again, if 2 points are very close to each other, then the slope of that line or that secant line becomes a tangent line. So 2 points are very close to each other where h is approaching 0. So what is differentiation or derivative means? It means slope of a tangent at a point on the curve. It's very important for you to know that dy by dx or differentiating a function at a point means finding the slope of a tangent at that point. Okay, so very important to understand this, right? Now, there may be many things to it, differentiability and all, but that's not what TMUA test you on. So, what they test you on is the process after that, and that is finding different derivatives and optimizing or the sketching a curve. All those kind of things is what is tested in TMUA. So, let's move on to that. So, first of all, we have to uh, in TMUA, only the derivatives of the polynomials or the rational functions is being tested, not trigonometric or anything is ever seen for differentiation in TMUA, right? Because it follows the syllabus of first year Cambridge, right? So that's why. So now, if suppose I say we have x to the power n, y is equal to x to the power n, right? So, or y is equal to fx is equal to x to the power n. So, dy by dx, that means the derivative of this, or we also say f dash x, is nothing but n x to the power n minus 1. And mind you, this is again what we derive by using the first principle, right? We can, but not again, derivation is not required. So, what we have to understand is the derivative of x to the power n is n x to the power n minus 1, right? For example, if I say y is equal to fx is equal to x cube, so the derivative will be dy by dx or f dash x will be 3x square. 3 will come here and you'll subtract the power by 1, 3x square. Similarly, dy by dx, or you can say if y is equal to fx is equal to x, so we can directly say dy by dx or f dash x is 1, right? Because power is 1, 1 will go here and 1 minus 1 is 0. So x to the power 0 will be 1 only. So that's what it is. Then if we look at dy by dx, if I have y is equal to a constant, say k, so dy by dx of constant will be 0. Just remember this. So these are some of the derivatives which you need to know, right, before we move on to anything else, right? But there are a few more things which I need to cover, right? Like for example, suppose I say if we have algebra of functions, like so if I say what is dy dx of fx plus minus gx, so it will be dy dx of fx, right, plus minus dy dx of gx. So you can separately differentiate if there are two functions which are separated by addition or a subtraction operator. So you can differentiate them separately. But the same does not apply when we are using the product rule. So gx, right? So in such a case, we say fx as it is, then dy dx of gx, we differentiate gx plus, then we keep gx as it is and we differentiate fx. So this is the product rule, right? So for example, suppose we have dy dx of 2x cube plus 5 plus 3 into x to the power 5 plus 1. So rather than multiplying, I can use product rule. So I say 2x cube plus 3 as it is into the derivative of gx. This is fx, this is fx, this is gx. So derivative of this will be, for x to the power 5, it will be 5x to the power 4, and for 1 it will be 0. Now I'll keep gx as it is, and then I'll differentiate fx, which will be 6x square. So this is the derivative of the product of these two functions. So this is something which we have to remember. Then, right, then we can have dy dx. If I say quotient rule, this is, you can say product. Now, if we use a quotient rule, in that case, dy dx of fx upon gx will be, we'll keep gx, the denominator as it is, gx, and then I will be differentiating fx minus, then I'll be keeping the numerator as it is, and I'll be differentiating the denominator. Mind you, in this order matters because there's a minus sign. Earlier, it doesn't matter the order. You differentiate any, keep any of them as same and differentiate the other because there's a plus sign in between. But here, order matters. First, you keep the denominator as it is, then you differentiate the numerator, minus you keep the numerator as it is, then you differentiate the denominator, and upon the function which is in the denominator's square. So this is quotient rule for you. Let me take a very small example, a simple example of this. Suppose I say dy dx of 2x minus 1 upon x square. If I have to differentiate, so I'll keep x square as it is. Differentiation of 2x minus 1 will be 2 only. Minus, I'll keep the, now the numerator as it is, and I'll differentiate the denominator, which is 2x, and then x square to the power 2. This is how we use the quotient rule. I'm not emphasizing too much on this because this is something which a TMUA aspirant is expected to know already, right? So, but still, a quick recap of all these things. What is more important is the definition which I told you, your understanding of differentiation as a slope of a tangent at a point. Very, very important thing, right? Now, let's move on to, again, tangents and normals. So, if we have a function, say y is equal to fx, y equal to fx is a function. And suppose the curve is given to us like this. So this is the curve. Now, if I have to find the tangent, this equation of a tangent at this point. So it is very similar to the process as we do in coordinate geometry of forming a or equation of a straight line, because tangent is also a straight line. So equation of a tangent or a normal. Now, what is a normal? Normal is perpendicular to it. And suppose this point x1, y1. Now, mind you one thing, this x1, y1 lies on all the three, the tangent, normal, and the curve. So it satisfies all the three equations. This is very important for you to know, right? So it satisfies all the three, tangent, normal, and curve. So if at a curve I have to find the equation of a tangent at a point, then the process is very similar. The only difference is that here the slope we will not be calculating by using tan theta or y2 minus y1 upon x2 minus x1. We'll be using it, we'll be finding it by using differentiation, because slope of a tangent at a point means nothing but the derivative of a function at that point. So everything remaining same, like for example, suppose I say we have a curve y is equal to fx equal to x cube minus 2x square. Now they say find the equation of a tangent at a point on a curve which is 1 comma minus 1, 1 comma minus 1. So what I will do is, I know the point. I know the equation. How do we form an equation? We could form an equation y minus y1 equal to m into x minus x1. This is how this is the equation of a straight line. And this is what we use. The only thing is I know x1 is 1, y1 is minus 1. I just need to know the value of m, and that is the slope of that tangent. So I can differentiate a function which will give me 3x square minus 4x, and I'll put x equal to 1 here, right? Since I have to find the tangent at this point, so x is 1 at this point. So if I put 1, so I'm going to get 3 minus 4, which is minus 1. So once I've got this, then the equation is very easy. Y minus y1 equal to minus 1 x minus 1, right? So this is y plus 1 is equal to minus x plus 1. So the equation is y plus x is equal to 0. Right, so this is the equation of the tangent at this point. But if we have to find the equation of the normal, the only thing is the point remains the same. We know the property that if two lines are perpendicular, then the product of their slope is minus 1. So m1, m2 is minus 1. And the slope of the tangent is minus 1. So the slope of the normal, say minus 1 into m2 is minus 1. So m2 becomes 1. So the slope of the normal is 1. So equation will be y minus minus 1 is equal to 1 x minus 1. This gives me y plus 1 is equal to x minus 1. So y minus x equal to minus 2. This is the equation of the normal at that. So we can find the equation of tangent as well as normal at a point very easily if we understand the process. And the process says that we know how to form an equation of a line that we have done in all in school days. In 10th also we have done that. So it is not nothing new for us. The only thing is that the slope here will not be calculated by the conventional way as we use in coordinate geometry, which is change in y upon change in x with y2 minus y1 upon x2 minus x1. Rather, we will differentiate the function and find the slope. That's the only difference, right? Let's move ahead. Now let's move on to curve sketching and optimization. Now for sketching, it is imperative for us to understand when is the function increasing and when is the function decreasing. Very, very important. So uh, a function is said to be increasing if, like for example, we have a curve like this, part of a curve which is like this. Now, if we look at this part of the curve, I know if I draw a tangent, or first of all, let's understand a simple method. Suppose this is x1 and we have a function y equal to fx. So this is fx1. This is suppose x2 and this is fx2. And as you can see in this part of the curve, x2 is greater than x1, I know that. But I can also observe that f of x2 is greater than f of x1. So on increasing the x value, if the y value also increases for a curve, then in that part of the curve, the function is said to be increasing. Increasing, right? And that's one way of understanding it. But how do we associate it with differentiation? That is very, very important. Now, if I draw a tangent at any point on this part of the curve, right? So if I draw a tangent, suppose like this, now this tangent makes an acute angle with the x-axis. And I've told you the slope is also defined as tan theta, which will be positive, which will be positive. So when the curve is increasing, so we have to understand if the curve is increasing, then the slope at that point is positive, right? Slope at all those points where the curve is increasing is positive. So if the slope is positive, that means, and the slope of the tangent also means dy by dx. So I can conclude that dy by dx will be greater than 0 at those points where the curve is increasing, right? So this is how we can associate it with differentiation. So they will give you an equation of a curve. In such problems, the equation of the curve will be given to you. So rather than checking x1, x2, what is greater, what is not, if x2 is greater or not, which is a very time consuming process, the easiest way of or finding the interval where the curve is increasing is just to differentiate the function and see wherever the derivative is greater than 0, right, it will be increasing. Similarly, if I draw another curve, suppose like this. Now here, suppose this is x1, this is x2, and we have y equal to fx as a function. So x2 is greater than x1, but fx2 is less than fx1. So as x is increasing, y is diminishing, decreasing. So such functions are called decreasing functions. But how do we associate it with the by the slope? I will differentiate it by slope by, suppose, any point if I draw a tangent. So this tangent makes an obtuse angle with the x-axis. Since it's making obtuse angle which is more than 90, so tan of an angle in the second quadrant, tan theta, right, which is slope, is negative because theta is greater than 90. Greater than 90 and of course less than 180. Because in the third quadrant tan again is 180. So for such case, I know that the slope will be negative. So slope is negative, so similarly I can say dy by dx is less than 0. Right? So it is very simple for us to now understand that whenever the derivative is positive, the slope is increasing, and if it is less than 0, then the slope is decreasing. So this is something which we have to understand, and uh, just to make sure how we solve it, if a question is given to us. So in form of a question, suppose I say fx is equal to, right, suppose 1 by 3 x cube, right, minus um, 5 by 2 x square plus 6x minus 7. Suppose this is the function, right? Yes, this is 7. And we have to find the interval where it is increasing or decreasing. Now, in the first chapter, I have covered quadratic inequality with you. So, if you feel any, any gap while I am doing this, you should refer to that video. So, I'll just find f dash x, and this gives me 3 into 1 by 3 x square minus 2 into 5 by 2 x plus 6 minus 7. Sorry, minus 0. Sorry, my bad. So it gives me x square minus 5x plus 6. Now this is the derivative. Now the interval in which I have to find whether it's increasing or decreasing. So just to solve those inequality, because dy by dx will be positive for increasing and dy by dx will be less than 0 for decreasing. So by method of interval, I know the roots are 2 or 3. And I've told you in that video that here the expression will be positive, negative, and then positive. So wherever the expression is positive, it is increasing. So I can see that the the function is increasing when x is greater than 3 or x is less than 2, and it will be decreasing when x lies between 2 and 3. Now, a lot of people ask me what happens at 2 or 3. So let's move on to that now. Let's understand that now. Now, since I have covered a curve, so I'm just making a curve, right? Suppose I make a curve like this. It's a cubic curve. It's a cubic curve. Now, understanding that here, if I look at these points, these are the roots, and if I look at this part, red part, here the function is increasing. If you look at the blue part, here the function is decreasing, and if you look at the green part, here the function is again increasing. So this is what we mean by increasing and decreasing. But the points, these points, right here, the function is, the slope is becoming zero. So slope is positive, negative for increasing and decreasing respectively, but the endpoints, the points of the interval, which I didn't include, like 2 or 3 in this case, at these points, you can see the derivative becomes zero because the tangent will be parallel to x-axis and the slope of the x-axis is zero. And if two lines are parallel, their slopes are equal. So I say the tangent at these 2 points are parallel. And these points are called points of local minima and local maxima. So always remember, whenever whenever the uh, slope is changing its nature from negative to positive. So in between, you generally find maxima or a minima where the slope is zero. Because if slope is negative and it becomes positive, it should move through zero. And if the slope becomes zero, the moment the slope becomes zero, so we say that uh, it's a point where the curve is changing its nature of curve from negative to positive, and the slope becomes zero. So those are the points of local minima and local maxima. And the values so obtained will be local maximum value and local minimum value, right? Local or relative also, we can use the term relative maxima, relative minima, or local maxima, local minima. So this is a point of local minima from this curve, and this is local maxima, right? So this is what we have to understand. So the points 2 or 3 I didn't include because there the function is not increasing or decreasing. The function has become stationary. So that's why these 2 points are also called stationary point. But then there is one more point which need to be addressed here, and that is where the curve changes its concavity. Concavity as in, like, in this part of the curve was concaving down, but after this point, suppose somewhere here, it has started to concave up. It has started to concave up. This point where the curve changes its concavity from concaving down to concaving up, or concaving up to concaving down, such point is called point of inflection. And here, the second derivative, if you differentiate function twice, the second derivative d2y by dx2 or f double dash x, this is 0. So at the point of inflection, the second derivative is 0. Sometimes at first derivative 0 also we can have a point of inflection, but that is a case of a function purely increasing or purely decreasing. There is function is not increasing also and decreasing also. Right, those we again, those things are rarely tested in TMUA, but the more important thing is that tracing of the curve, how we make a curve. So the process here is like, if we have to understand ki, okay, now the same equation, I know increasing decreasing I did. So fx is equal to, suppose if I say 1 by 3 x cube minus, or 1 by 2 or 5 by 2 x square plus 6x minus 7. Suppose we have this equation. It was plus 7 minus 7. Let me check. It was minus 7. Now we have seen increasing, decreasing. But how do we find out the points that we got 2 or 3 are the points of maxima or minima. Let's understand. So if I find the first derivative, I will be getting x square minus 5x plus 6. If I put it equal to 0, why I am putting it equal to 0? Because at the point of maxima and minima, the slope of the tangent is 0 because they are parallel to x-axis. So I'll get point x equal to 2 or 3. 2 or 3. 2 or 3. This is what I've got. But if I have got this, right, we are not sure which one is the point of maxima or which one is the point of minima. So I'll find the second derivative, which gives me 2x minus 5. If I put 2 here, so on putting f double dash 2 gives me a negative value, and f double dash 3, sorry, f double dash 3 gives me a positive value. What that value is doesn't matter. This is called second derivative test, which again you must have done in school, right? So nothing new for you. So second derivative test, if it is less than 0, it is negative. So if it is negative, then then 2 becomes the point of maximum, and 3 becomes the point, and since f double dash 3 is positive, 3 becomes the point of minimum. So what you have to understand is, on putting the first derivative equal to 0, the points that you get are points of maxima or minima, maybe point of inflection also sometimes, but generally speaking, point of maxima and minima. But to ensure which one of them is point of maxima or minima, we find the second derivative and then we put the values so obtained in the second derivative in case of x. So if I get this negative value, then it's a point of maxima, and if I get a positive value, then it's a point of minima. So 2 in this case becomes point of maxima and 3 becomes the point of minima. Now let us understand, if I have to trace this curve, if I have to draw this curve, this is very important for TMUA. So how do I draw it? Right? Because we do not have graphing calculator with us. So if I have to draw this curve, so how will I draw this? So to draw this curve, I have to find the value at f of 2. My function again is, I am writing it once again, 1 by 3 x cube minus 5 by 2 uh, x square plus 6x minus 7. Now I will find the value at f of 2, right? Let me find the value of f of 2. So f of 2 will give me 8 by 3 minus 10 plus 12 minus 7. So I know this is a negative value, right? So f of 2 gives me a negative value, whatever the value is. Now let me find f of 3. F of 3 will give me 9, 27 by 3 is 9, minus 45 by 2, which is plus 18 minus 7. So if I look at this, so 3 is a point of minima, but it gives me a negative value. And f of 2 is a point of maxima, but again it is a negative value. And I know it's a cubic equation. The curve, I know it will start like this. At suppose 3, we have a point of minima. So 3 is here. At 3, there is a point of minima. So it's like this. This is 3. 3 it has attained a minimum value, and now it will turn. It will not be same because it's a point of minima, so it has to turn. So 3 is a point of minima. Now, point of maxima, right, lies just besides it at 2, but it again is a negative value. So rather than crossing the x-axis, it will go like this. So this is how this curve will be. The curve will be increasing from infinity to 2 and then from 3 to infinity, and it will be decreasing between 2 and 3, but the curve looks like this. So often in CAT we get questions, okay, how many roots are there for this cubic equation? So the number of real roots for this cubic equation will only be 1, right? And also remember, if we put the second derivative as 0, second derivative was 2x minus 5, 2x minus 5, if I put it equal to 0, so I get x equal to 5 by 2. 5 by 2 will be here, right? 5 by 2 will be here, sorry, and 2.5. And here the curve is changing its concavity from concaving down to concaving up. So it's called point of inflection. 2.5 is a point of inflection. So this is how we trace the curve or we draw a curve, which is very important for us to understand, right? So these are the basic things which are required in differentiation: finding the function tangents or equation of a tangent and normals, just to check where the function is increasing, decreasing, and also wherever the function is minimizing, or you can say local minima and local maxima. More importantly, how we draw a curve using this, right? So that's all for this video, right? Next video will be on integration. Do watch this video. More importantly, watch a video on the questions that I'll be covering, right? Because that will give you the entire application part of whatever we have studied in this video, right? So see you then. Take care. Have a nice day.